name is Markus from Dijk. I'm from SURFsara. We're interested in using Docker, experimenting with it. And actually, I'm presenting ourselves here to get some understanding with you of what we're doing, so that you hopefully can help us. So first thing is, what is SURFsara? And it's, we support researchers in the Netherlands with computing power and also data storage. And let me see, well, it's actually quite an old institute. It was founded in 1971. We had one of the first supercomputers. And currently we have supercomputers. These are our facilities. Cartesius is the supercomputer. And we also have a GPU cluster. Lisa is a grid system. There's another grid. I assume that everybody's familiar with the term grid. Yeah? Okay. Recently we also have a Hadoop cluster, and we have a cloud. And it's the grid and the cloud that we are focusing on, because we're trying to see how Docker can be interesting. The main problem is that we have the hardware, and our users, the researchers, they have developed a program or use a program.
Analyze our data, but they're not in any way computer savvy. Some of them are, but most of them are not. So we have two of these solutions. One is the grid, where you have we control the environment, and you just have your program and your data. You launch jobs, and you get the result, which is easy for the user. But it means that they're in a very controlled environment. So if you have special needs, then that's a problem. The other extreme is the cloud, and that's a roll your own. That's infrastructure as a service, which means that you can assemble your VM any way you like, and you install your own operating system, and everything is yours. Of course, in this case, you have to know a bit about computers. Now, I'm going to baffle you with this slide. We have quite some computing power. Well, I only have 10 minutes, so I won't dwell very long. But it's quite a bit, and it's heavily used by our users. As I said, it's infrastructure as a service. So you as a user have to administer everything. But you are flexible. You can have a VM of up to 32 cores. There's quite a bit of memory in there. You can have disks up to 2 terabyte. Well, you can just load every operating system you like. Most of them use Linux, but there are several people that insist on Windows. There's of course internet access. That's the difference with Amazon, where you pay for your internet connection. There's a private network between, if you launch more than one VM, you have a private network between your VMs, so that's completely secure. And of course you have the internet. And there's also, we found out that people tend to share information between the VMs, so we made a sort of network drive. The link with Docker is that we also have persistent and non-persistent disks. The non-persistent disk is like with Docker. You start up your system with a copy of your disk, and then afterwards, if your VM is closed down, shut down, then it's thrown away. There are also persistent disks where you directly use your disk, and of course, in that case, you have two VMs using the same disk. See, yes, there's a console possible for web access, and of course, whatever you install there for communication is fine. Some people like SSH and command line interface, and others really need things you click. What we use, well, here are some usage data. There are a lot of research fields that it's used for. Well, I think you probably don't know. There are a lot of packages that are used like Galaxy, RStudio, or MATLAB. There's also number crunching and DNA sequencing and things like that. So it's often quite big data and big number crunching. The other one was grid computing. The grid is a lot of computers scattered out over Europe or the Netherlands. And you launch your job, you don't know where it lands. You get it back at some point. And this is good for lots of, well, if it's embarrassingly parallel, you can just launch a lot of jobs at the same time and just wait. And some of the jobs will die, so you have to have sort of an administration system. Well, you probably are familiar with the SETI at home and Folding at home. There's also the European Grid Initiative, where, well, for instance, data from CERN, like the Higgs particle was discovered. It's also done on machines from South. There's a Dutch grid. We have 15,000 cores. That's NICF, that's for higher energy physics, which is the University of Groningen. And also astronomy is a field where they generate well, I think they generate about 2 petabytes a year of data and can't throw it away. Because you've measured it, it won't happen again. Every year we have 2 extra petabytes to store. There's a small part of the grid, it's the life science grid, which is 11 clusters scattered over the Netherlands, and it's dedicated for life sciences computation. The way it works is that all these machines run a similar operating system, actually the same. They all have the same libraries installed, and there's a middleware to make sure that everything works together. Of course, if you need those libraries, then you're fine. If you need another version of the library, well, then you're in trouble. There's a system to make it a bit easier. It's in general, you have to make do whatever is installed in the grid. Now, for these 2 systems, we have some possibilities for Docker. I saw that there was a Docker cloud in OpenStack. That may be a good alternative to the cloud that we now have, which uses VMs. But it's not completely secure. There's a difference in security between the containers and a real VM. So how do you manage that in a way that an unknown user, unknown to us, cannot take over the system or influence other systems? And of course, there's also the limitation of shared OS. Now they have complete free choice of the OS. In this case, for the pound, the OS that runs under Docker. I'm doing that bit, so please, if you have any information, come to me. I'd like to know of people who have run Docker in well, similar circumstances. And for the grid, there's Jeroen Schot sitting over there. And he's interested also in the Docker system because now the jobs run on, several jobs run on the same computer, which also means that they sort of can see each other. Of course, we have shut down the directories, but still. And it would be nice to have a clean environment, like a Docker environment, where you know that you're the only one that can demolish anything, and as soon as your job ends, everything is gone, and there's nothing left in /temp or whatever. But also there, if we would allow arbitrary people to start Docker commands, well, they can become root in their container, and who knows what they'll do there. So that's acceptable. Then how can we solve that? If you know anything about these topics, we're very interested in learning from your experiences. Any questions? I can't believe that I was attempted.
You mentioned that the disadvantage of a cloud environment is that the user has to know how to install an operating system, has to manage that stuff, but Docker does not solve that problem. With Docker, you still have to install EOS, or actually just use an image, but you have to know how to install software into a Docker container. So what is the advantage of using Docker over the cloud in your case?
We're thinking of startup and shutdown speed. Because, well, there's one example of a guy who has a 50 terabyte disk. And if we want to start that, we have to transfer that 50 terabyte from the machine where it lives to the machine where it should run. Well, it takes an enormous amount of time. And that would be better.
I think I have a solution to your problem. The previous guy was just joking about running a cluster in an image. There you have it. You use your own operating system for your customer. And you have some of those tooling configured, maybe through interface available to your client.
Yeah, what we do now is what we do now is that for people who are not so really computer savvy, we have a wizard that installs a Linux system for them. And basically after that, it's theirs. Because we're not going to maintain that. So they do have to have some knowledge about it. Otherwise, they shouldn't be on the cloud. Or maybe that in their group there's someone who can do it for them. But we don't have the manpower to maintain their environment. And you're right, we don't change that. And for in the grid, maybe we can offer some pre-configured containers of things that are happening often.
At least you can offer, I think, versions. Like you can offer some configuration management on this configuration within the current version or downgrading.
Well, yeah. It's always, if your software runs on this with this version of the library, why change it? It's always asking for trouble. But then sometimes it's really a demand of a certain program. It has to have exactly this version of that library. Well, in this case, in Docker, you can do that without disturbing anyone else in the system. Yep. In that case, I hope you come to me with all the solutions. Thank you.